All right, here we go. So again, I don't know if I'm going to do any specific ones, but I'll at least show you what style of problems are on there, what number they are, and all that kind of stuff. I revised the quiz that I gave last year. It was only 5 questions, and then I took one question that had like 4 parts to it, and I made it its own question, all right, just to spread it out a little bit. And I added a couple extra graphs that I didn't have on last year's. All right, so number 1, whoops, gotta go to this, go to this. All right, now let's try it. Number 1 is going to be, I'm going to give you a function or an equation, and you have to tell if it's symmetric with the origin. Symmetric to the origin. All right, so that was from 3.1, I believe. And do you remember that one? That's if, yeah. When I taught it to you guys, right? I put negative y, but let's do it this way.
This way makes
Sure, it does. So if this is equal to negative f of x, then it's symmetric to the origin. I think this makes more sense, to tell you the truth, because I'm going to give you, I said I wasn't going to do an exact one, but let's just do it. So what if I said f of x is equal to, I'm looking at the examples. They say x to the 5th. All right, so there's my function. So I give you a function, and you have to tell me if it's symmetric to the origin or not. And you got to show me why. You can't just say yes or no, all right, and get 50-50 shot. You got to show me why. Everybody understand that? Okay. Remember we talked about the odd and even ones? I changed my mind, and I want you to show me why it's odd or even, and not just say, well, it's because that thing is an odd number, then it's odd. I want you to show me why. Because this has to do with the odd and evens as well, doesn't it? Remember that? So if I go f of negative x equals negative f of x, that's also showing me if it's odd or even. Which one would this be? This would be... That's correct. And yes. So this would be the same as if it was an odd function. What was an even function? We're not at that problem just yet, but what if it was an even function? I'd put f of negative x would equal what? Which is positive f of x, the original, okay? So let's do this. I like showing it this way instead of saying, just change the y's and that kind of thing, because, I don't know, it makes more sense because it's given to you as f of x. So what are we going to do? We're going to replace the x with a what? With a negative x. So here's our function x to the 5th, so I'm going to replace that I'm going to replace that x with a what? A negative x. Everybody see that? So now let's work this thing out. Okay, let's simplify it a little bit. So what is a negative anything to a 5th power? It's going to be negative, isn't it? So this is going to be what? Negative x to the 5th. Do you see that? All right. So does this fit this? It does. Because when I replace the x with a negative x, I get negative whatever my function was. My function was x to the 5th. Look what I ended up with. A negative function. Well, there's only one with the origin. It's almost as easy. Nah, it won't be anything like that. It'll be a fairly basic one. Won't be quite this easy, but it'll be something like it. All right, let's do one that's not going to be on the quiz, like you just said. Again, I'm just looking at the examples. This is example A, and this is A, and this is B. So what if you had g of x equals x, write that right, over 1 minus x. Yep. All right, what if we had this? Is this symmetric to the origin or not? Well, what are we going to do? We're going to replace every x with a what? With a negative x. So I'm going to go negative x over what? 1 minus negative x. What's 1 minus, let's just show it. 1 minus negative x. So it's negative x over what? 1 plus x. Is this the same? Okay, I'm sorry. Is this the same as, I'll put equals question mark, okay? Is this the same as negative x over 1 minus x?
Yeah. No.
It's not. It's not, because look, if I multiplied this by a negative, I'm not multiplying the top and the bottom by a negative, right? I'm just multiplying the top. So what would this be? That would be negative x over what? 1 minus x. Is this the same as this? Are they the same?
Wait, why are you only multiplying the top?
Because that's how we multiply fractions. Right? Look, if I had, I don't know, 2/3, and I multiplied 2/3, what's that?
This is 1/1, not
If I multiply, no, but watch, it's a fraction like this. This is a fraction, correct? Because you said, why did I only multiply the top by the negative? It's the same thing here. If I multiply this by a -1, what am I doing? Am I multiplying the top by a negative and the bottom by a negative? No, because if I did, then that would be a positive 2/3. But what's -1 times 2/3? It's just negative 2/3. Okay? So I'm only multiplying the top by the negative. Technically, you could multiply the bottom by a negative as well. Or not as well, but you could just multiply the bottom by a negative, because 2 over -3 would be the same exact thing as -2 over 3. Make sense? But for the most part, when we multiply that by a -1, we just take the top. So that's why I only multiplied the x by the negative, right? I don't multiply the bottom by the negative, so it stays the same. So here's my question. Is this, question mark, is this the same as this? No, obviously not. That's negative x, which is the same, right? But look at the bottom. This is 1 plus x, this is 1 minus x. They are not the same. So is this symmetric to the origin? No. Is this symmetric to the origin? Yes. But I got to see why. I do not give you a fraction on the quiz. On the test, that's definitely a possibility. Okay? On the quiz, I'm just telling you right now, I am not. Make sense? Okay. Let's see. Now, number 2, well, actually 2 through 5. You have to see if I give you a function or an equation, and you have to tell whether it is symmetric to the following. All right? So the following would be the x-axis. Number 3 would be the y-axis. Number 4 would be the line what? Y equals x. And number 5 would be the line, what was the other one? Y equals negative x. So how do I know? Let me find an example from the book just so that, okay, here's the formula or the equation that they give you in example 2 on section 3.1, xy equals -2. So there's the equation they give you, and you want to find, is this graph, this is a graph, right? You could graph this thing, okay, but is it symmetric to the x-axis, the y equals x, or y equals -x? So how do I know? What's my test to see if it's symmetric to the x-axis? Change the sign of the y. Keep the x the same, but change the sign of the y. And let's see if it's going to be the same as this. Okay? -2. So what's this going to be? Negative xy, correct? Equals -2. Simplify it a little bit further. Get rid of that negative. Multiply both sides by a negative. So that means xy is equal to what? +2. Is that the same as what we started with? It's not. So is it symmetric to the x-axis? No, it's not. Would you agree? Right? Because xy equals 2 here, but xy equals -2 there. They're not the same. So no, it's not symmetric. Let's do the y-axis. And show me why. I need to see all this. Okay? Don't just write no. Because if you just write no, even though that's the correct answer, I'm marking it wrong because I need you to show me why it's not. Everybody got that, right? So no whining and crying if I mark it wrong. And Mr. Hamrick, I got it right. Not if you didn't show me, you didn't get it right. What about the y-axis? What do? Change the x and keep the y the same. And let's see if it ends up to be the same as this. Well, you see it's going to be the same thing as this one, don't you? But let's write it out anyway. It's still going to be negative xy equals negative 2. Multiply both sides by a negative, so xy equals positive 2. That is not the same, so no, it is not symmetric to the y-axis. What about y equals x? What do we do with that? Just change the x and the y. So instead of xy, what's it going to be? yx. Is that the same thing as this? Yeah, it doesn't matter what order you multiply those. So yes, that is the same as this. So what do we say? Yes. All right. And then what do we do here? That's right. We change the order, right? We put a y in for the x and we put an x in for the y, and we switch the signs. So what would that technically be? It would be negative y times what? Negative x. And let's see if that equals negative 2. Well, negative times negative is positive. This would be yx equals negative 2. Just switch the order. xy is negative 2. Does that end up to be the same as this? Yes, it does. And there you go. So those are your tests right there to see if it's symmetric to those 4 things. It's not hard to do. It's just remembering the test. All right, so that's 2, 3, 4, and 5. So you're halfway done the quiz. Who's got 100 so far? Good. All right, 6 is odd or even. We kind of talked about that when we did number 1. All right, so I'll give you something and you tell me, is it odd or is it even? Again, if it's odd, what does it have to, what's our little test for odd or even? F of negative x will equal what? We did it for the origin. It's the same as the origin. Negative f of x. Remember that? If it's even, what is it? Again, you make the x negative or opposite, and what should that equal? The original function. Okay? So that's how you can tell if it's odd or if it's even. Now, there are situations where it could be neither. All right? So if neither one of those things is true, all right, if you put a negative in for the x, you don't get a negative original function, or you don't get the original function at all, you get something completely different, then it would be neither. So you always have that option as well.
What's the point of saying it's an odd or even?
There are reasons later on, like in calculus and stuff. I can't tell you a specific example, but I do remember doing that stuff in calculus, and you have to know whether it's an odd or even function, and it does certain things to it, and that kind of thing. So we're just preparing for stuff that's going to happen later on. So right now, it doesn't make much difference in our life, but eventually, it'll come into play. All right, now we got graphs. So the rest is just graphing. So I made it pretty easy on 7 and 8. So 7 and 8 are just parent function graphs. Parent function. What does that mean? It's just like your main ordinary graph. You're not moving it to the left, you're not moving it up, you're not squishing it, you're not expanding it, right? You're not doing anything. It's just a regular graph. So just know them, right? We went through a whole bunch of them. We had x squared, right? A parabola. We had x cubed. We had greatest integer function, maybe. Which I'll give you a hint. No, I don't give you a greatest integer function. You could have absolute value. Were there any other ones we did? Could have a straight line, but I'm not giving it. The 1 over x, okay, would be a possibility. Well, the step function would be that greatest integer. I said I'm not going to put.
1 over x is an inverse function.
Yes, it is. Yeah. So we took notes on it. We listed a whole bunch of those. So go back and look at your parent function. So 7 and 8, you don't have to move it left and right and all that stuff. Now, number 9 and 10, what do you think you're going to do? These are all graphs, by the way. So 9 and 10, you do that translation stuff, right? Translation means you move it up or down, left or right. All right, so I'm going to put some stuff in there. That would be kind of like this. We just talked about that when we went over the homework. It wasn't on YouTube, but we talked about it when we went over the homework. And so what does that h do for you? If it's x minus h, we move it that many places to the right. What if it was x plus h? Then we'd move it to the left. Okay, this is plus k. That means we move it up or down. Okay, if it was minus k, we move it down. If it's plus k, we move it up. Now, what does this thing do? I'm going to put a plus or minus out in front. Yeah, it makes it skinnier or wider. Very good. Okay, so what number would make it skinnier?
2.
Yeah, anything larger than 1. Okay, anything larger than 1 would make this a skinnier version of that graph. Right? How could I make it wider? What number would this be if I made it wider? Anything between 0 and 1. That's right. Okay? You follow me? So if it's a fraction, now if it's a fraction that's less than 1, right, like 3 over 2 is a fraction, but that's not what we're talking about. We're talking about any fraction between 0 and 1. I put plus or minus right here. What does the plus do to my graph? Your graph would go up. That's right. And what does the minus do to that graph? It would make it flip it. It would make it go down. All right, it would just flip it. Make sense? All right, yeah, we talked about that enough. And that's your quiz right there. So you're taking the quiz on Thursday. Today's Tuesday. You got a field trip tomorrow. And then we'll take the quiz on Thursday. And then we'll continue on Friday with our regular learning stuff. Everybody good?
Yep.
All right, that's it.
Really, Will?
Yes, I will take your homework before you leave.